I want to welcome Caitlin and Flavio back up. I think Flavio first. And we're doing an in the lab session using the COMPAS Dataset.
Yeah.
And welcome.
Hello everyone. I hope you're still awake. This is the last session. I know everyone is tired. It's been 2 days, but get ready to get your hands dirty now. We're going to be working with code and looking at a data set. So fire up your computers, turn on your laptops. And the first most important thing is that we're going to be working with one specific data set called the COMPAS Dataset. Make sure you download the notebook that we're going to be walking through. You're going to be looking at during this presentation. The GitHub link is right here. Hopefully most of you have downloaded it. There you can have access to the data and so on. If you haven't, go to this link now. I'll leave it here just for a few seconds so you can get it.
Or if there's any internet problems still, I have the data on
Okay, so also the hope is that you, this is an interactive session, so I hope that you guys will talk about your results and talk about what you find in the data. So maybe to get it started, I just want to say that this is, I think this is something that I'm really passionate about, which is using data science for social good. Both Caitlin and I were involved with a program at IBM called the Data Science for Social Good Fellowship. And today we're going to be looking at one specific aspect of how we can do data analysis for the social good. In particular, how can we identify biases and ensure fairness in machine learning algorithms. But before we get there, I just want to ask you a question. How can data-driven analysis be used for the social good? This is an intentionally vague question, but I just want to get you all participating in this conversation and in the mindset of what we're going to be doing today. So how can data-driven analysis, how can data science be used for the social good?
When analysis is made publicly available, it can help inform the public and keep people accountable, things like that.
Mm-hmm.
I guess in medical domains in education,
Yeah.
about like different applications of just where we have data with predictions about decision procedures.
Yeah.
We can use it for making policy.
Yeah.
Or for transparency.
Yeah.
So we need to let them see how the process should get sorted.
Great.
You can use it for justifying claims, so people make claims and you can keep them accountable based on the data.
Yeah, so these are all great answers, and you guys are all right. Like, there are many different applications, many different fields where data science can have a very high impact, and basically, and also be a source of positive transformative force. And these are some applications that we mentioned, right? You can talk about using data science for accelerating scientific discovery in medical diagnosis, operations management and optimization, resource allocation. So we want to optimize school bus transportation. We can optimize, for example, resource allocations for NGOs. We can look at how data science can impact governments and issues like transparency, businesses, and so on. But today we're going to be looking at one specific aspect of this, which is using the data science to develop critical consciousness. And what I mean by that is use data, and this is a subtle aspect, but it's more of an educational aspect, which is use data to understand your reality and identify political and social contradictions that surround you. In that sense, data science is a very powerful tool because you can collect data from your community or data about a system, in this case that we're going to be looking at today, on criminal justice and so on, and use that data to identify biases and maybe through your algorithms avoid that these biases propagate. So we want to recognize, the goal of today is to recognize in one instance if machine learning methods are propagating or enforcing certain biases in society, and use that understanding to take action against disparate impact. And what I mean by disparate impact is having the output of an algorithm or the decisions made by that algorithm having a disparate impact among different social demographic groups. And of course, we want to do that in a scientific way. We want to do that while keeping the science in data science. So hopefully you will keep in mind that it's not just a matter of looking into a data set and identifying biases, but it's a question of measuring these biases right? And being able to generalize this and use this in a systematic way in different applications. Questions? Anyone has thoughts on this or that they want to share? Okay, so today we're going to be looking at one specific data set, and this is a data set that you've probably heard a lot through the last 48 hours, which is the COMPAS recidivism data set. And this data set has been gaining a lot of attention, basically because it's one specific instance where we can measure and study if a machine learning algorithm, or basically an algorithm, is giving unfair risk assessments to different defendants. So what is recidivism? So let's start with that. So recidivism is a tendency of a convicted criminal to reoffend, right? So if you charge a defendant with a crime, recidivism is the risk that they're going to go on to commit another crime. And risk assessment algorithms, algorithms that assess recidivism risk, are used in courtrooms in the United States to identify the recidivism risk of defendants. And that's used in many different states. So basically what happens is that often in many places, if you're convicted of a crime and you're arrested, someone is going to fill out a questionnaire about you, or they're going to get that questionnaire from your criminal records, they're going to feed it to an algorithm, and that algorithm will give you a score, and which is the score of committing a new crime. And this score is actually used by judges. It's used for many different purposes, most notorious of which is to set bail. Right, so this score can be given in certain states to a judge. The judge will look at that score and they'll decide, oh, this person got a 7 out of 10, so maybe we should give them a slightly higher bail to make sure that to keep them in prison. And there's one specific algorithm called the COMPAS algorithm. This algorithm was developed by a company called Northpoint Inc. It's a proprietary algorithm. We really don't know what's in that algorithm or how that algorithm works. But it gives you a score based on 137 questions that are answered by the defendant or pulled by their criminal record. And the fact that this algorithm is proprietary is a little bit concerning, right? Because this is something that's used for decisions of individual level consequence. This is a pretty big decision, like if you're going to recidivize or not, what is the bail that you're going to have to pay. And this algorithm, despite being used in legal decisions, it's a black box. It's proprietary. We can't really analyze how the algorithm makes this decision. But we can look at the scores that it assigns and look at how it's correlated with different social demographic factors. So recently, ProPublica published an article where they argue that this algorithm is biased, where they look at the data, they collect data from and particularly that this algorithm is biased against African Americans. And the way they did that is that they collected a bunch of data about COMPAS scores, about different defendants. They correlated it with, they got additional data on their criminal records and so on, and did an analysis on that and made that data public. So basically, they have information in COMPAS score of about 7,000 defendants. And a very important feature that they get is actually the true recidivism of each defendant or not. Basically, what that means is that you have the COMPAS score that was assigned for that defendant at the time that they were arrested. And you also have if they recidivized 2 years afterwards. So what you can use that for is to not only assess what is the distribution of COMPAS scores between different social demographic populations, but you can also see how accurate this prediction is. And on top of that, you have a lot of information about different features of the defendants. You have things like gender, race, age, and you also have some other features in this data set, things like degree of charged crime, if it's a misdemeanor or a felony, you have prior counts, length of time between when they committed the crime and when they were arrested, and so on. Any questions about this data? So just to be clear, this analysis is from ProPublica. Like this data, we got it from their GitHub repository. Yeah.
So is 2 years considered the time frame for? So why 2 years?
That's a good question. I'm not entirely sure. They actually have. You're going to see in the data they have recidivism. So basically, if someone recidivized or not, and a 2-year recidivism. I understand where they're coming from for why they're capping them out of time, because you also want to, you don't want to look way into the future of a defendant. Why exactly twice as 3 years? I'm not sure.
It could also just be that was what we built.
Yeah, so it's basically, I think it's also from the time frame when they collected the data. Exactly. Any questions? Okay, so this is the intended learning outcomes for today. So today you will analyze the COMPAS recidivism dataset and the score bias between African Americans and Caucasians. So you will compute on this data different fairness metrics using this dataset and debate what these metrics mean and how they can be improved. And really, this is not me telling you what it means. Hopefully you guys will go through this analysis and come to this conclusion on your own and have your own interesting interpretation of what's happening. And also, by looking at this data, I would be very curious to see if you can suggest, maybe not in this 1.5 hour that we have for this analysis, but eventually suggest your own metrics and visualizations for capturing fairness and identifying discrimination in these settings. And again, try to generalize your methodology. Like we're going to be looking at one specific data set, but try to think how you can incorporate this thought process and these tools into your own data mining and analysis pipeline. Okay, and I also understand that here in the room we might have beginners and more experienced people in data science. So we're here to help. I'm sure that everyone can get something meaningful and from this exercise and accomplish some of these goals today. So, but if you need any extra help or anything like that, please let us know, and we'll be happy to give you some guidance. And specifically, we're going to be looking at 3 tasks. So the first task is the simplest task. I'm going to give you some time just to make sure that you can load the data and verify that you can manipulate it, that you can correctly load the data on your laptop and run the first cells of the IPython notebook. And then we're going to focus on 2 different exercises. The first one is verify the COMPAS score without taking into account recidivism rates. So here I want you to look at this. What I mean by that is to look at the scores given by the algorithm like a black box. You know, assume that we don't know the true recidivism of the defendants. We don't know if they actually went on to commit new crimes or not. Just look at the scores that the COMPAS algorithm gives to each defendant. It's a score from 1 to 10. And look at the distribution. Is it different between Caucasians and African Americans? We're going to be focusing on those 2 groups today. Mostly because the other groups, for example, Latino and Hispanics, we don't have enough data points in the data set for that. These are by far the most amount of points that we have. And the example questions that you're going to be trying to answer is something like, are the score distributions for Caucasians and African Americans that are over 45 similar? And particularly, like, you're going to notice an imbalance in the scores, but when you condition on different attributes, age, gender, does that score change, or do we continue to perceive this bias between this COMPAS score distribution? And the third question that you're going to be looking at is then compare the COMPAS score, the score between 1 to 10 that this COMPAS algorithm gives you for your recidivism risk, with the true recidivism rate. So is it giving an accurate prediction? Is it committing more errors for example, one group, for Caucasians or African Americans? What is the balance between the error rates, right? And how sensitive is this to decision thresholds? So when do I declare that someone recidivized? When the score is above 7, 6, right? How does this thresholding process influence the accuracy of the algorithm? So these are things that hopefully you can see in the notebook, and you can also, if you want, write your own code to do that. So just to make this clear, these tasks are already coded in the notebook that you can download. So you have 2 options. You can either follow the notebook directly and just tweak some of it and see what it's doing and look at the visualizations. Or preferably you can try to write your own code and create your own visualizations and your own analysis for this. And again, the hope is that this eventually serves as a basis for identifying fairness in your own data science pipeline. Any questions?
So afterwards, what's going to
So okay, so the first task, we're going to go through all these 3 tasks. I'm going to put the task here, then I'm going to give you some time to accomplish it. I'll give you how much time for each task, and then we're going to regroup, have a small discussion, and move on to the next task. So now for the next 10 minutes, I'm going to ask you guys to group up, maybe in pairs or groups of 3, I don't know, or more, however you feel comfortable with. see if you can load the data and verify that you can work with it on your notebook or on your laptop. And Caitlin and I will be here to help you. So I guess maybe for the next 10 minutes, you guys can keep up, load the data, and as soon as everyone is pretty much set up, we'll move on to the next task. Okay. Races here for African Americans and Caucasians. For this second task, try to produce visualizations. You can do that by directly executing the notebook, or try to create your own visualizations that look something like this. This is the distribution of COMPAS scores for African Americans and Caucasians from 1 to 10. As you can see, there's a huge imbalance between these scores, but try to verify this yourself. Don't take my word for it. And this is another sample visualization that you have in your notebook. This is a little bit more complicated to parse, but it might be useful because this gives you the average COMPAS score, the percentage difference of average COMPAS score between Caucasians and African Americans for different groups. So what each number here means is the percentage of how much higher the score is for African Americans than compared to Caucasians, conditioned on different categories. So for example, if you're between 25 and 45 and were charged with a felony and have 0 prior counts, you haven't committed a crime before, the difference is 15%. The difference here is much higher. If you look at, for example, defendants that are over the age of 45 and committed a misdemeanor but have more than 3 priors, the gap between the average COMPAS score between African Americans and Caucasians is much higher. You have a 48% higher score for African Americans. But again, don't take my word for it. Try to do this comparative analysis either directly or looking at different social demographic groups in your notebook and see if you can also recover this difference in scores. And the kinds of questions that you should be trying to answer are the following. Is there a bias in the COMPAS score distribution between African Americans and Caucasians? And does conditioning on other features, degree charged, prior count, affect the distribution of these scores? Is there some kind of Simpson's paradox phenomena happening here? By that, what I mean is that when you condition on certain other features, maybe this bias disappears. So try to verify this for yourself. And in the next task, we're going to do this for taking into account true recidivism rates and start a discussion about the precision of the COMPAS algorithm, at least in this data set. But for now, try to answer these questions and produce visualizations that look like this. So maybe we'll put 15, 20 minutes on that, or maybe 15 minutes, and then we'll discuss our results. Is that okay? Anyone have any questions or concerns?
Variables, so for both values. So what we see is that it sort of makes sense. So if they didn't commit a crime, the scores tend to be lower, and if they did, the scores tend to be higher. But if we look at the Caucasian, but what we see is that it's not the same distribution or skewness to the left or the right. But instead, if we look at when Caucasians did commit a crime, the scores are not skewed to the right. It means they're not higher. Instead, they're like they stabilize. They flat. Yeah, it's like a uniform. So we think there is a bias in that part.
Turns out it's several thousand, at least. So
Yeah,
it should be significant.
it's pretty significant. Relationship between accuracy and fairness of your mechanism. I mean, you want your mechanism to accurately predict recidivism, but at the same time, you want your algorithm, right, to give a fair result, to assign similar scores independent of, for example, race or gender or something like that. So hopefully you guys get a taste of exactly how this tension appears within this data set. Another thing we didn't take into account was also the number of samples, which I mentioned earlier. None of these plots have error bars, and I think that's very important to understand. Or when you condition on, for example, greater than 45 with exactly 2 priors and charged with a misdemeanor, and let's say Caucasian, does that group become very, very small? Can I still make meaningful statements about that? Yeah. And another thing you guys can do afterwards, and I think someone had suggested that, is also a more fine-tuned correlation analysis to see if there are other attributes, and we didn't do this, that are correlated to race or gender. because then that indicates that, and you can observe this by doing prediction on this data set, that even if you drop the race feature, you and trains, for example, logistic regression or something like that, you may observe still a disparate impact on the scores. So there's some indirect discrimination, like information about race, for example, is encoded in other variables. So that's something that you could do
I
afterwards.
was thinking about
Yeah.
dropping the race and training and checking the model again on the data, the test data, and see how different is the
Yeah.
result.
Yeah, so that's something you should definitely do. And it's a really worthwhile exercise to do.
What methodology did you guys use to choosing these 10 attributes?
So these attributes follow the analysis from the ProPublica dataset. So what you see there in Python is basically repeating the filtering that they did for the original article. So that was the methodology, but I don't want to advocate that that's the right methodology or not. They simply mimicked what they had done before. Okay, so let's move on for the third task, and I think this one is even more interesting, which is asking the question, does COMPAS accurately predict true-year recidivism? And in particular, how can we repeat this fairness analysis and this distribution analysis that you were doing, now taking into account true recidivism rates? And you might have noticed in the data that we have this feature called recidivism and true-year recidivism that indicates if the defendant recidivized 2 years after being charged with a crime. So we're going to be working with the 2-year recidivism, but they're basically the same in this data set. The kind of questions that I would like you to keep in mind while incorporating the true recidivism rate into your analysis is, does COMPAS accurately predict true recidivism? Is there a difference in prediction accuracy between African Americans and Caucasians? What that means is that, is there more false positives or false negatives between Americans compared to African Americans compared to Caucasians? And how does this rate change between groups? And make sure to discuss your results. And of course, a question you might have, and want to share this with you guys, is how can we measure this disparate impact, right? Can we do this in a little bit more systematic way? I'm going to present you 3 scores that you may want to look at. This is already coded up in your notebook, but you might want to try to implement this yourselves. These metrics, I borrowed it from this paper by Choda from 2017. It's a recent paper that analyzes this data set. And for the purpose of presenting these metrics, I'm going to introduce some notation. The first one is Y will represent the true recidivism. S is the COMPAS score. SQ is the quantized or thresholded COMPAS score. What that means is that you might want to say that if the score is above 7, this SQ is 1, which means like it's a high chance of recidivism. And if the score is below 7, this SQ is 0. So basically thresholding it at a given level. And R is race. So here are 3 scores you may want to look at. The first one is calibration. So for a given threshold Q that you choose, this is the difference between actual recidivism rates, given that your quantized COMPAS score is 1 for different races. So let's say you say you set a threshold of 5. And the question is, if the threshold is larger than 5, and what is the true recidivism rate between African Americans and Caucasians? And if there's a big difference in this, you would assume that the COMPAS algorithm is giving you an imbalance in their prediction. So, of course, you might be asking, oh, why did you say 5 as a threshold, right? We might want to look at different thresholds and see how that affects your scores. So this is what they call, I define this here as predictive parity. So basically, what is the true recidivism rate, Y equals 1, given that your COMPAS score is larger or equal than a certain value S for a given race, African Americans, divided for Caucasians. So this gives you the ratio, the difference between the true recidivism rate, given that you received a high COMPAS score. And the last thing that's in the notebook and you might be interested in analyzing is the error rate imbalance. So what that means is that for different thresholds S, in this different decision thresholds here, what is the false positive rate for African Americans divided by the false positive rate for Caucasians? Is there a difference? So do you observe, for example, across all thresholds, a much higher false positive rate? Basically, you're indicating that African Americans will recidivize, but they don't actually recidivize at a much higher rate than for Caucasians. So these are 3 metrics that you might want to look at, and they're in the notebook. But if you have other suggestions and you have other metrics that you also find interesting, feel free to code them up and let's see how they perform. And a question is, what values of these ratios would I consider what is the difference between these ratios that I would consider discrimination or not, that I would consider fair? And just as a guideline for you, I suggest the US Equal Opportunity Commission Act. Like this is the US EOC, and they have a rule of thumb for disparate impact, which is the so-called 80% rule. And this is just a rule of thumb. This is not law or anything, but these are their guidelines. And where they adopted the rule of thumb, where generally they consider that a selection rate is biased, or there is a disparate impact if the difference is larger than 80%, if the difference is larger than 20%. So basically, this ratio here is smaller than 4/5, or larger than 5/4, for example, or this difference is 20% larger. So if, for example, the true recidivism rate is within 80% between African Americans and Caucasians, that would satisfy, or like this the ratio between false positive rate for African Americans and Caucasians, if one is within 80% of the other, maybe that's okay. But if it's larger than that, you would have a disparate impact. Of course, this is not law, this is not a fixed number, but maybe this is just a threshold to guide your thought and your discussion. Okay, so I'll leave this here on this slide here for you guys to look at these different metrics and look at the data and see how they perform, and see if when we take true recidivism rates into account, what kind of biases, if at all, we observe on the COMPAS algorithm. Okay? Any questions? Okay. These results. So anyone wants to start sharing what they observed?
The ratios on certain thresholds were in the peak. Right. The PPS on the majority of thresholds was quite off. We should also consider that is a ratio-based metric, so it's prone to getting rather large values quickly. And this was in contrast to the ORAC curves, which actually showed a rather small difference because they document the absolute differences in performance.
And I think it's interesting to point out that this predictive parity metric, it showed up in the Northpoint's response to the ProPublica article. So, for example, if you look at the curve that you have in the notebook, you see that the lowest point for the difference in predictive parity is at 7, which is kind of the point that they suggest that the algorithm operates. And I think the takeaway message for this is that a lot of these metrics are, they vary a lot depending on parameters such that where you threshold your score. And this can be used both for trying to identify bias and discrimination, but also by people who design these algorithms should maybe just shift the numbers a little bit and justify that there is no bias and discrimination. So this process is hopefully something you will take with you when you're doing your own data analysis and analyzing these different metrics and trying to judge if the machine learning model you built is fair or not.
I want to talk about the predictive parity curve that we had. As you just mentioned, it may be 7, maybe the score the threshold that we want to have for fairness, but it may not be the same if we are looking for prediction accuracy, right? So we have to have probably there like a trade-off, right? And try to explain why we are making this decision, because we also want to make this the most accurate as possible, right?
Yeah. Anyone has any other comment, observation, thought?
Well, I guess some of our conversation centered around like what are other measurements that might be good to use. I'm jumping to the next slide, sorry. but just one thing we were talking about was like if you could design some measurements that would get at this idea of like a negative feedback loop that was talked about a little bit this morning. So we were thinking about looking, well, what do you want?
Sure. Well, I'll say a little bit and you jump back in. So what we were thinking about was how do you kind of get at an estimate of how likely somebody is to be reconvicted once they're initially convicted, and we kind of called that the like sort of conviction growth rate, you know, within a population, because obviously if you're before a judge and they're like, oh, you already have 2 convictions, you know, they're more likely to sentence you than if they're like, you're squeaky clean, you know, get out in the world and do something, you know. So we want to try to bake that in, so that the sort of the heat map that you showed us, you could see what was actually driving those trends, and so that you could do some within ethnic group sort of normalization, and then make a comparison. Because if, as an African American, you're much more likely to be reconvicted once you've been convicted once, then making an absolute numbers to numbers comparison is inappropriate. And so we're looking at that, and also thinking about some ways to sort of look at, in the previous section, the shapes of the distributions, and make comparisons of the actual shapes of the distributions to see how different they really are. You know, because our eyes our brains are, I think, are maximally trained to find difference. But the question is, are those statistical differences, or are those sort of, you know, eyeball differences? And so we thought we could do like a Kolmogorov Smirnoff test to look for the differences in those distributions.
Yeah, nice. It's a very good idea. Okay, so yeah, so you guys, oh, sorry. So yeah, we if you guys work on this data and develop new, I think there's a lot of more interesting analysis that you can do beyond the one that was done here. You can create your own like predictors to try to identify recidivism risk based on this data set. You can do correlation analysis to see if there are specific features that explain away the COMPAS scores better than others, and if race or gender are among these features. There's a lot of stuff you can do with this. So if you play around with this data and have some neat examples, we would love to look at your code. If you wrote code today for this analysis, we would also love to report you on GitHub. This is and to see how we can really extend this debate about fairness forward. And the COMPAS dataset is a new dataset. There's definitely a lot of interesting things we can say about that. So here's our emails here. Again, if you have any thoughts about this process, any feedback, I don't know, or if you incorporate some of this in your own research, we would love to hear about it. So yeah, just shoot us an email, and if you want to continue discussing this, yeah, I would love to talk. So yeah, thanks.